Hello and welcome to Honors Function. In this lecture, we're going to be working with the first two types of polynomial functions, linear functions and quadratic functions. We're mostly going to be applying these to real-life situations. But first, let's look at the average rate of change of a linear function. So this is a linear function and we know what the graph looks like, but let me look at the average rate of change, for example, in the interval x1, x2, okay? You should have the intuition of what the answer will be if you remember the graphical interpretation of the average rate of change. Let's go through the work though. So it's f of x2 minus f of x1 divided by x2 minus x1. So it is ax2 plus b minus ax1 plus b over x2 minus x1. So it is ax2 plus b minus ax1 minus b over x2 minus x1. The b's will cancel. Let's now factor a. It's a times x2 minus x1 over x2 minus x1. And that cancels and we find a. We find the coefficient of the leading coefficient, which is also the slope of the line, right? Let's look at it graphically. You know what the linear function looks like. It looks like a line. For example, here we go. F of x equals ax plus b. A is the slope of the line. What you do when you find 2 points there, like let's say this is x1 and this is x2 right here, we know the graphical meaning of the average rate of change. It's a slope of the line going through the 2 points x1, y1, x2, y2. y1 is right here and y2 is right there, okay? But the slope of the line is going to be exactly the same as the slope of the whole graph, which is just a. Okay, so it makes sense. If we were to do that on a quadratic function, so a quadratic function, the standard form would be f of x equals ax squared plus bx plus c. We would not find a, actually. But there's a way to get it as a constant. This is part of a class assignment. We will see that. It's kind of pretty interesting. Let's go now with the first examples, real-life application of linear functions. So here we go. A salesperson is paid $200 per week plus 5% commission on her weekly sales of X dollars. So every time she makes X dollars, she's going to be given 5% of X dollars, right? 5% of X dollars. Okay, I think I get it. Plus the fix, that is 200 a week. Find a linear function that represents her total weekly pay. Okay, so W, if I call it W, weekly pay, is a function of her weekly sales, X dollars. So it's going to be 200 plus 5% of X. So plus 0.05 times X, right? And that is her weekly pay. Okay. What must her weekly sales be in order for her to earn $475? So weekly sales, don't forget, this is X, right? This is weekly sales. So we want her to earn $575. So we want the weekly pay to be greater than or equal to 475, sorry. 475. So the inequality should be pretty simple. 200 plus 0.05x greater than 475. So that means x is going to be greater than 475 minus 200, 275. 275 divided by 0.05. 0.05 is 5 over 100, which is 1/20th. So you multiply, sorry, here's another mistake. It's 275 right here. You multiply 275 by 20. 275 times 2, 550 times 10, 5,050. Please, 5,500, sorry. Please do not forget to answer with a sentence. So her weekly sales must be at least, I'm gonna say at least $5,500. Okay, here we go. That's it. Good. Second example. Let's go now over the second example. When the owner of a computer game sells a popular game at $40 per unit, player will purchase 60 units. When she sells the games at $45 per unit, buyers will get 50 units. In addition, each unit cost the store $25. That's a cost to the store, right? To buy the game. Find the linear function D that represents the number of games sold per week. So we are told the number of game is a linear function, and I do have 2 points, right? The input, so find the linear function D that represents the number of games. That's the output, right? This is the output. In terms of, so that's the input. So let me write the 2 points that I have. Input 40, output 60. Input 45, output 50. Okay, how about we use the point slope form of a line, and then we'll write it in a linear function after, okay? So the number is called D. D minus, I'll take this point, D minus 60 equals the slope, 60 minus 50 over 40 minus 45 times, and the other variable is P. P minus, so 60 goes with 40. Here we go. That's the equation. So this is 10 and this is 5. So it's negative 5. So it is negative 2p. Negative 2 times negative 40 is 80. 80 plus 60 is 140 plus 140. And this is the number of D as a function of P. This is a linear function that represents the number of games sold by the store in function of the price of the game. Okay. Find the function C that represents the weekly cost to the store from purchasing the games. So that's a number they will purchase, right? If they sell D, we assume they're gonna purchase D. So the cost, it's called C in function of the price, is just gonna be the number of game, D of P, times the cost to buy a game, which is 25. So it is, you multiply this by 25, so it is negative 50p plus 140 times 25. So 140 is 140. 100 times 25 is 2,500. 40 times 25, 4 times 25 is 100. 100 times 10 is 1,000. So it's plus 3,500. Here we go. So this is the cost to the store. Okay? All right. I'm gonna let you work on question 3, 4, and 5. Let's go now over a very important type of quadratic function that represents free fall. So this is a very important type of equation, guys, that represents free fall. You need to know it. Okay, so S of t, so let me show you right here. You are dropping, so here's the y-axis and the x-axis, and let's say the original position is right here. We call that S naught, the initial position. S naught can be 0, it can be negative, it can be positive, okay? And right here you are either dropping an object. If you drop, that means you just let it go from rest, okay? Or you can throw it, and if you throw it, you can, it goes like this, right? It's gonna go up and then it's gonna go down, right? You throw it up. All right, you could, I guess, throw it down maybe, but that we would have to be, the velocity, the initial velocity would have to be negative if you throw it down. But anyway, so the equation of, that represents, let's throw it up. Here we go. I don't think we're gonna see example when we're gonna throw it down, okay? I want to keep track of the position of the object. So for example, right here, I'm going to call that S right here of t, and this is actually gonna be the time. Okay, so S of t represents the height of the object t seconds after it was thrown. So S of t is, I'm giving you this equation. You need calculus to derive this equation. It's not difficult, but you need calculus. And the first law of motion, oh my gosh, Newton first law of motion, okay? So S of t is negative 1/2 of g times t squared plus v naught t plus s naught. V naught t is the initial velocity, okay, assuming you're throwing it up. If you're throwing down, then I guess you would have a minus v naught t right here, but that, I haven't seen that, okay, happening. If you are dropping the object, okay, so v naught will be 0 if you're just dropping, if dropped, okay, because you don't have an initial velocity. And S naught is the initial position. So again, S naught can be 0 if you on the ground, right? S naught equals 0 if on ground. Okay? All right. This is a very important equation. You need to know it. What is G? G is the constant of acceleration. So if you're measuring height in feet, G is 32 feet per second squared. It's an acceleration. If you're measuring height in meters, G is going to be 9.8 meters per second square. So you need to be looking at the problem to see what they measure the height with. International system of units or the Brits. All right. There is another equation that is important for you to remember. It's the velocity at any time. So right here, suppose the object is here, it will have a velocity. We call that v of t, okay? And the velocity of the object after t seconds of free fall is v of t is negative gt plus v naught, okay? Negative gt plus v naught. So please remember these two equations. I may give them to you, or I may just ask you to remember them. I don't know yet. Okay, let's go over an example now. I'm going to let you do number 6, and I'm going to tackle number 7. So what are you doing in number 7? You're dropping a large log over the edge of the Grand Canyon. Oh, don't do that or you'll be arrested, okay? And it takes 5.65 seconds to hit the ground. So here we go. Here's a very Grand Canyon, like that, right here. And you're dropping your log, and it takes, the time is 5.65 seconds, okay, to hit the ground. Calculate the velocity of the log at impact, and calculate the distance the log fell in meters. Okay, let's write the two equations describing the motion. One is for the altitude of the log. So it is negative 1/2 gt squared plus v naught times t plus s naught. And the other one is for the velocity of the log. So it is negative gt plus v naught. Okay. We are dropping the log. That means there's no initial velocity. This is 0 right here. This is 0. And we do not know S naught, that's the original altitude. That's what we're looking for, right? Calculate the distance the log fell in meters. Meters means G equals 9.8 meters per second squared. Okay, so that's easy. Now we can get the velocity right away. The velocity after 5.65 seconds is negative 9.8 times 5.65. So if you take your calculator, you're going to find that it is negative 55.37 meters per second. Negative because we are orienting the axis like this. This is a positive direction, up, and the log is going down. So negative, it's going the opposite way of the positive orientation. This is kind of fast. Let me tell you what it is in kilometers per hour. In kilometers per hour, so let's see. Every second you're covering negative 55 meters. So if you multiply this by 3060, I use my calculator, you would find negative 199,332 meters per hour, right? I multiply by 3060 because that's a number of seconds in an hour, by hour, and then you divide by a thousand right here. So oops, it's a dot. So that's kilometers right here. It's about 200 kilometers an hour. That's pretty darn fast. Okay, and we also need to figure out the altitude, the height of the Grand Canyon, or whatever you throw it from. So how do we do that? Well, we're just going to be using this equation right here. It takes 5.65 seconds to hit the ground. When you hit the ground, s of t is equal to 0. So here it's s of 5.65 equals 0. So that means s naught equals 1/2 of 9.8 times 5.65 squared. And if you use a calculator to type that in, you would find that it's about 156.4 meters. That's the altitude. It's pretty high. You threw the log from. Okay? I will let you do all of the other example. I'm going to stop this video right here. Thank you for watching.